Okay, so let's quickly go through question 6 on the jacaranda galvanics and fuel cells test. The answer for this question was C, but how did we get there? Well, number 1, I need to point out that this is wrong. This here should be a 3. Okay, it looks like I've made it an 8 there, but it should be a 3. So it's CR3+. Now, in order to work out what all the coefficients are going to be for this full equation, we need to look at the half equation. So, text here, for oxidation, well, it's the oxidation of iron sulfate. Sulfate is a spectator ion, so therefore oxidation is Fe2+. It's oxidation, so oxidation is loss, so we're going to actually have electrons in the product side. We're going from iron 2+ to iron 3+. So only species there that are relevant, plus 1 electron, because it's 2+, so 3+, we've lost 1 negative electron. Cool, that's our oxidation reaction. Our reduction reaction is going to be our dichromate, and that's going to be 2 negative. So we've got our dichromate, 2 negative, it's going to be plus electrons on the reactant side, because it's gain of electrons, reduction, and we are going to produce our Cr3+ ion. And I'm not putting states in here just because it's tricky to write this all out, but you should be putting states in. So I have my chromium 3 ion, I have my dichromate. Is the chromium balanced? No, I've got Ca2 here, I've just got 1 here, so I need 2 of these. Now, I still haven't balanced my oxygen here. So, nice and simple, let's bring this in here, nice and simple, plus, if I have 7 oxygen on one side, I need 7 water on the other. And then, of course, if I've got in total 14 hydrogen on one side, I need to have 14 hydrogen on the other side. So now looking at this, chromium balanced, hydrogen balanced, oxygen balanced. But how many electrons are being gained in this redox equation? We know it's chromium that's being reduced. Exactly how many electrons is each chromium gaining? We can't just say it's 14 because it's not, firstly. It's not always the amount of electrons that balance the hydrogen. Sometimes it works out that way in certain equations, and that was nice and simple for another one I talked about during this test, but I do not want you thinking that you balance your number of H+ with your number of negative electrons, because that's not right. It's actually about how many were gained to reduce these chromium. And to do that, we need to assign oxidation numbers. So Cr2O7 to negative. If we're assigning oxidation to this chromium, we look at this oxygen. We say there's 7 to negative oxygen, which means overall that's negative 14. The overall molecule has a negative 2 charge. Therefore, these 2 chromium here must have an overall positive 12 charge. So the chromium in dichromate equals, just want an equal sign, equals +6. That's the oxidation number for each chromium in dichromate. What about over the other side? Yeah, once we've undergone reduction. So we've gained electrons, we should see a low oxidation number, and we do. Each one equals +3. So each one has gained each one has gained 3 electrons, and we have 2 this side, 2 this side, so overall 6 electrons has been gained. Now, when we put 2 half equations together, we need a balanced number of electrons. If we have 6 electrons in this half equation, then we need 6 electrons here, which means we must have 6 iron 6 iron. So combining these two together, now we've written out the half equations, gives us 1 dichromate for A, gives us 6 iron ions for B, and it gives us 14 hydrogen for C. Okay, so this is a long process. I wouldn't think this should be a multiple choice question. I think it's too tricky for a multiple choice question, but it's a really good process to go through, and it could be a very good short answer question.